To the SLB, or Server Load Balancer portion of the course, we'll get started by introducing some basic server load balancer concepts. So when you first start building a web service or web application, you have a relatively small number of users, and at that point it's okay to put your site or application on a single server. You might not want to do that for reliability reasons, but let's just start our example by assuming that your site is deployed on a single server. Of course, eventually, if your web service becomes popular, the number of users grows, and then you need to start splitting your service up across multiple servers. But the problem then becomes, how do you allow your users to seamlessly access these multiple servers? You can't give each of them a different URL. You can't give each of them a different domain name and then expect your users to remember that. That's too much work. That also doesn't help you deal with failure. What if you did give each machine a separate domain name and then one of them failed? Well, the users who are accustomed to using that server wouldn't be able to reach it anymore and might not know how to reach the other servers. So you need to have some kind of an interface in front of these multiple backend servers. That is what Server Load Balancer is. It's a machine that sits in front of your backend servers and distributes incoming requests evenly across them. That's what a load balancer does, and that's what Alibaba Cloud's Server Load Balancer does on the Alibaba Cloud platform. So Server Load Balancer is a traffic distribution control service, that's what it is, that distributes incoming traffic among multiple ECS instances according to a set of forwarding rules that you configure. It has built-in high availability. It has 99.95% service uptime across multiple zones. It's scalable, so you can scale your services without interrupting service continuity because the Server Load Balancer is sitting in front of your backend servers. If you need to replace or upgrade some of them, Server Load Balancer can route traffic away from those machines that are being upgraded or replaced. Therefore, you can avoid downtime. It's low cost compared to building your own load balancer. There's a price reduction of around 60%, and it has built-in security. So of course, like our other Alibaba Cloud products, it defends against DDoS attacks of up to 5 gigabits per second. Like ECS, OSS, and our other core services, SLB is available across all 22 regions and 66 zones that Alibaba Cloud has worldwide. So no matter which region you choose, you will be able to deploy SLB. Next, we'll take a look at some of SLB's key features. Let's now turn our attention to some of Server Load Balancer's features and take a look at Server Load Balancer's architecture. Alibaba Cloud provides two types of load balancer. There's the Layer 4 load balancer for routing TCP and UDP traffic, and then there is the Layer 7 load balancer for routing HTTP and HTTPS traffic. Now, the Layer 4 load balancer is based on LVS, Linux Virtual Server, plus Keep Alive D. So you can see in the diagram on the lower right here that TCP and UDP traffic is passed to a LVS cluster and then passed to the backend ECS instances. It's the fact that we're using a cluster that allows us to provide high availability in the Server Load Balancer. In Layer 7, for Layer 7 traffic, so that's HTTP and HTTPS, we use Tenjin, which is a web server based on Nginx. So our routing is done via Tenjin rather than LVS. But the concept is similar. We have a cluster of Tenjin servers that pass traffic back to the backend ECS instances. So for Layer 4 Server Load Balancer, both TCP and UDP protocols are supported. The incoming client connection is bound to the server connection. What that means is the load balancer is transparent to the user. So the user's traffic passes through the load balancer unmodified and is routed back to one of the backend ECS instances with no header modification. So the traffic is not modified in any way. Now, the Layer 7 load balancer works a little bit differently. So it supports HTTP and HTTPS, and the connection that the user makes to your site actually terminates at the load balancer itself, which means that the load balancer can examine the HTTP stream and can modify headers. This is good because it means you can make intelligent routing decisions based upon the content of the connection, but it also means that when you send the traffic to one of the backend ECS instances, you do that by opening a new HTTP connection from the load balancer to the backend ECS, which means that if the backend ECS needs to see the user's original IP address, they have to get that from the X forwarded for header in the HTTP connection. They can't just check the source IP address of the incoming connection because that will be the load balancer rather than the user's IP. So keep that in mind when you're using the layer 7 load balancer. Next, we'll turn our attention to some of Server Load Balancer's key components and functions. In particular, we'll take a look at how listeners are configured. Okay, next let's take a deeper look at some of SLB's key components. So we'll start with the load balancer instance, the listener, and the backend server. These are the three critical components of Alibaba's Server Load Balancer system. The load balancer instance is a running copy of the load balancing service that's under your account that's bound to a particular region, and what it does is receives incoming requests and distributes them to your backend servers. So how does it listen for those incoming requests and how does it distribute them? Well, the rules for that are contained in the listener. Every SLB instance must have at least one listener. This is the component that decides what to do with incoming connections, where to send them, and it also performs health checks on the backend servers to make sure that they're healthy and that traffic can safely be distributed to them. The backend servers themselves are nothing but ECS instances. They are ECS virtual machines that are waiting and listening for the requests that are coming in from the load balancer. Okay, let's talk a little bit about cost optimization. So currently, Alibaba Cloud SLB only supports purchasing in pay-as-you-go mode. If you purchase what we call a public SLB instance, then you will pay for instance usage and for public network traffic. You'll be billed for the exact volume of resources that you use per hour. There's no long-term commitment or upfront fees here. You're paid only for what you use. There's another mode as well. We have a private network SLB, and that is free. So if your server load balancer is internal to an Alibaba Cloud VPC group, if it doesn't if it doesn't accept incoming connections from the internet, then it's totally free. So you can use internal server load balancers for free. However, if your load balancer is accessible from the public internet, then you need to pay for it on a pay-as-you-go basis. There are two general instance types. There's the Classic and VPC Network SLB. Classic Network, you don't need to worry about that. No new instance classes support the Classic Network. This is something from before Alibaba implemented the VPC system. Essentially, in the Classic Network, all Alibaba Cloud clients share one big private IP address space. And so sometimes in our documentation or in the console, you'll see references to this old Classic Network system. Whenever you're setting up a new load balancer, though, or a new ECS, you should always choose VPC Network. So the load balancer that you want is the VPC load balancer. And if you provide a public IP, then what you've done is set up a public server load balancer and you'll be charged for that. If you don't give your SLB a public IP address, then it's a private server load balancer and you can run it for free. One advantage of having this public-private network SLB system is you can take advantage of this to create a multi-tier architecture. So you can have multiple internal private server load balancers sitting in front of internal tiers of your application, and then a single public load balancer sitting in front of your web server tier. So in this way you can achieve elasticity and high availability for the internal tiers of your application as well as for your external web tier. So you get a great trade-off here between performance and cost. So let's talk about listeners. So listeners define the protocol and port on which the load balancer listens for incoming connections. Each load balancer needs at least one listener to accept incoming traffic. Each load balancer has to have at least one listener. The listener defines three things: the routing or forwarding rules, so how traffic is distributed among backend instances, whether or not session stickiness is enabled. This is also set at the listener level. Essentially, this means that an ongoing web session with a particular user will always be forwarded to the same backend server for the duration of the session. That's session stickiness. And then health check configurations are also done at the listener level. So checking whether or not the backend servers are functioning is done at the listener level. There's one thing that's not set at the listener level, that's peak bandwidth. Peak bandwidth is set at the instance level. So when you purchase your SLB instance, you're deciding what its specifications will be, how many queries per second it can respond to, how many concurrent sessions it can handle, peak bandwidth. Those are all set at the instance level, but the listener defines routing rules, session stickiness, and health check. So on the listener, there are different types of forwarding rules or scheduling algorithms. There's three. There's round robin, weighted round robin, and weighted least connections. So how do these work? In round robin, requests are distributed evenly across all of the backend ECS servers. So if you have 3 servers, let's call them A, B, C, then incoming requests will be distributed like this: A, B, C, A, B, C, A, B, C. So the request will always be distributed sequentially and evenly across the backend instances. In weighted round robin, again, requests are distributed sequentially, but they may not be distributed evenly. With weighted round robin, you can set a weight for each backend server. This is a great thing if you have backend servers that have different hardware configurations, because you can set higher weights for servers that have more CPU and memory available. That way those servers will be allocated more connections. Then there is WLC, weighted least connections. In addition to setting a weight for each backend ECS server, the number of active connections is also considered when new requests are distributed among the backend servers. This is good if your application has long-lived sessions or connections. This will avoid a pileup. So if an instance already has multiple active old sessions, then WLC will avoid giving new sessions to that server and will give them to a different backend server that has less active connections instead. Limitations of the listeners: you can have up to 50 listeners per server load balancer instance, and typically each listener corresponds to one application that's deployed on your backend ECS servers. Why is that? That's because each listener has one port number that it's listening on. Backend servers. So the backend servers that sit behind your listener are just ECS instances. These are the servers that you've added to your server load balancer server pool or vServer group in order to handle incoming requests. The SLB service will forward external requests to these servers according to the rules defined in your listener. And ECS instances can be registered with the same load balancer using multiple ports. What that means is multiple listeners can send requests to the same backend ECS instance on different ports. That is allowed. Limitations for the backend servers: no cross-region deployment. So all of the backend servers behind your load balancer need to be in the same region as the load balancer. So if your load balancer is in Hong Kong, then your ECS servers also need to be in Hong Kong. They can't be in Singapore or Beijing. However, there's no limitation on the operating system. As long as your backend servers respond to requests in the same way, it does not matter what they're running. You could have half of them running Linux with Nginx and the other half running Windows with IIS. That would be totally okay, as long as they respond to requests in the same way. Backend server groups. Because the IP address presented by the SLB creates a single interface through which all the backend servers are accessed, multiple ECS instances located in the same region can act as a highly available server pool. And there's 2 different types of server groups that are supported depending on what type of listener you choose. If you choose a layer 4 listener for TCP or UDP, then we have what is called a master-slave server group. This is the backend server pool. This is essentially just to provide HA, not really to provide true load balancing. The master, all requests are distributed to the master when it's working normally. If it goes down and fails its health check, then all requests go to the slave. Things are a little bit more sophisticated for the layer 7 listener. We have what we call virtual server groups. So you can add multiple ECS instances into a virtual server group, and you can even configure domain name or URL-based forwarding rules to decide which of those servers, which of those ECS instances inside the group will handle which requests. Health checks. There are actually several different types of health checks that the listener can perform depending on the protocol of the listener. For HTTP or HTTPS, the health check is fairly simple. The server load balancer will send an HTTP head request to each backend ECS server, and it will expect to get back an HTTP status code like 200 OK. If it doesn't get the code it was expecting, then the server fails the health check. For TCP, things are a little bit more complex. For a layer 4 listener, during the health check, what happens is the load balancer will send an SYN to the backend ECS. It will expect back an SYN plus an acknowledgement, and then it will send an acknowledgement and a reset. If it gets through that whole process, 1, 2, 3, 4 steps, if it gets through all 4 of those steps, SYN plus ACK, reset, then the instance is considered healthy. If it doesn't get an acknowledgement back at step 2, if it doesn't get SYN plus ACK back from the backend server at step 2, then the instance fails the health check. UDP, is a little bit unique. TCP and HTTP are both protocols that have a concept of a connection, right? So in those two protocols, you have an expected challenge response that should take place to show that the backend ECS is there and working. With UDP, that's not the case because UDP is a connectionless protocol. So what happens is the server load balancer sends a UDP probe to the backend ECS server, as you can see in the diagram here, and it expects to get nothing back. If it doesn't receive a response within a certain duration, then it considers the backend ECS to be healthy. If it receives an ICMP unreachable error within its timeout window, then it considers the backend ECS to be failed or unhealthy. So that's a little counterintuitive. For HTTP and for TCP, you expect a response. That's how you judge health. For the UDP health check, you expect to get nothing back. If you get a response back to the health check, that means the health check failed. But in any case, this is all implemented for you inside the listener, so you don't really need to worry about how this works exactly. Just know that if the load balancer detects that an instance is unhealthy, it can automatically stop sending new traffic to that instance, which will help ensure the availability of your service. Okay, that's all for this section. In the next section, let's take a look at Server Load Balancer's additional settings. SLB Additional Settings. Let's first talk about multi-zone disaster tolerance. So you can use the primary backup zone feature in SLB to implement multi-zone disaster tolerance. So how does that work? Well, essentially, within an Alibaba Cloud region such as Singapore or Hong Kong, what you will do is set up backend ECS instances that span at least 2 different zones, and then you'll attach those instances to your server load balancer. And by default, server load balancer is configured in a multi-zonal way, so there will be a primary and a secondary zone, and you just make sure that the primary and secondary zone you select for your SLB matches the 2 zones where your ECS instances are deployed. What will then happen is if there's a failure in one of those 2 zones, the server load balancer will detect that internally. It will make sure all incoming traffic from the internet is thereby routed to the still running, still active server load balancer service in the other non-failed zone, and will route all requests to the running ECS instances, ignoring the ECS instances in the failed zone. And that all happens within about 30 seconds. When the primary zone comes back online, again, server load balancer will detect that and will once again begin distributing requests across both of those zones equally. If you want to achieve cross-region disaster tolerance, things are a little bit different. You can't achieve that with SLB alone because server load balancer cannot span multiple regions. You now need to include some DNS failover capability. So Alibaba Cloud DNS has a built-in health check mechanism that you can turn on. And at the DNS level, if DNS service realizes that one of your load balancers is unreachable, say in the China East 1 region, then it can stop routing requests over to that region and start routing them to the server load balancer in your healthy China North 1 region. With a deployment of this type, you're able to survive both a single zone failure and a single region failure. By distributing across multiple zones and multiple regions, you can tolerate the failure of both a zone or a region. So this gives you the maximum failure tolerance capability. But you do have to make sure that you've implemented your application in a way that allows this kind of a configuration. One issue to resolve, which is not shown on the slide, is how you're going to synchronize, say, a database between these 2 zones. Of course, you can do that. We do provide tools for that, which we discussed in the RDS section of the course, but you do need to be aware that a multi-region architecture is more complex and requires more advanced planning. Auto-scaling. One of the key reasons that people use Server Load Balancer is to integrate with our auto-scaling service so that they can scale their web application or web application backend up and down with demand. So this auto-scaling feature allows you to do a couple of things. You can maintain instance availability, ECS instance availability, by detecting impaired ECS instances and replacing them automatically. And you can also use auto-scaling to grow and shrink your pool of ECS instances on demand. So how does Server Load Balancer fit into this? Well, auto-scaling and Server Load Balancer are integrated in such a way that auto-scaling can tell Server Load Balancer to add or remove instances from its backend server pool. So when the autoscaling service grows the pool of backend servers, it can link the new servers up to Server Load Balancer. When it deletes unnecessary servers, it can remove them from the Server Load Balancer to make sure that all the Server Load Balancer requests are being distributed evenly across this pool, no matter how many ECS instances are in the pool in total. SLB security. SLB provides protection against DDoS attacks up to 5 gigabits per second via our built-in anti-DDoS basic. All traffic from the internet goes through this anti-DDoS service before it arrives at Server Load Balancer, and anti-DDoS can defend Server Load Balancer against multiple different attack types such as SYN flood, UDP flood, ACK flood, ICMP flood, DNS, query flood, NTP reply flood, and HTTP flood attacks. So it has very sophisticated attack detection mechanisms. And again, up to 5 gigabits per second, that service is provided for free. If you experience a lot of high volume attacks, you might want to consider upgrading to Anti-DDoS Pro. So if you look in the Server Load Balancer console, you'll see what the black hole threshold and cleaning threshold are for a given Server Load Balancer. That 5 gigabits per second, that's the high-end protection that Anti-DDoS offers, and that scales actually with the size of your load balancer instance. So at the cleaning threshold, that's the traffic level at which the Anti-DDoS service is triggered and begins to scrub attack traffic. The black hole threshold is where the Anti-DDoS service is unable to continue protecting your Server Load Balancer effectively and shunts all incoming traffic from the internet into what is called a black hole, meaning none of the traffic reaches your load balancer. That's done as a protective measure to protect your load balancer and the servers behind it, but it does mean no one can access your site. And if you're curious what exactly those thresholds are for a given Server Load Balancer, you can mouse over the little shield icon, which you can see in the left-hand side of the screenshot on this slide. You can mouse over that in the load balancer console and you'll see what your thresholds are. The largest Server Load Balancer instances will have a black hole threshold of 5 gigabits per second, as I mentioned on the previous slide. Smaller Server Load Balancers may have a smaller protection threshold. For instance, the SLB shown here has a traffic scrubbing threshold of 300 megabits per second. So when traffic reaches the 300 megabit per second level, Anti-DDoS will be triggered and will start filtering traffic. And then it has a black hole threshold of 1.2 gigabits per second. So this load balancer will start throwing away incoming internet traffic at the 1.2 gigabit per second threshold. So actually before 5 gigabits per second. If I had purchased a bigger, more capable load balancer, then my free protection threshold would be higher. And again, if you need more protection than that, you can turn on Anti-DDoS Pro for any type of server load balancer, any type of public server load balancer, and that will provide protection well up into the hundreds of gigabits per second. Okay, and now a quick recap. So Server Load Balancer is a fully managed, scalable, and highly available load balancing service. You can host multiple different applications behind a single server load balancer by configuring multiple listeners for that load balancer. And the load balancer service integrates with auto scaling, so you can scale your backend server pool up and down on demand. That's it for this section. In the next section, let's have a hands-on demo and see how Server Load Balancer works in practice. Let's now try out Server Load Balancer for ourselves from the Alibaba console. So I'm here on alibabacloud.com. That's our official website. I will go over here to the upper right-hand corner and click on Console to enter the web console. And I've already set up 2 ECS instances to act as the backend servers behind our Server Load Balancer. So let's go look at those first. So if I click here on Elastic Compute Service, that will take me over to the ECS console. I can navigate to the Singapore region where I have these 2 servers running, and I'll show you what's happening there. So I have these 2 different servers, one called ECS-A, that's in Zone B, and one called ECS-B, which is in Zone C. I've given them public IP addresses for now so that I can log into them and show you what they're running. You'll see that ECS Instance A is running Apache and has a web page that simply says ECS Instance A. Same thing for Instance B. If I visit its public IP address, I can see the ECS Instance B page. And I've actually put different pages on each instance so that when we put them behind the load balancer, you can see that the load balancer is in fact distributing requests evenly across these 2 instances. If they had the same HTML boilerplate code here, then you wouldn't be able to see any difference. So I've intentionally put slightly different index.html files on each of these two web servers so that you can see that there is in fact a difference between the two of them. So now what we need to do is go set up our server load balancer, configure a listener, and also create what's called a vServer group or virtual server group. So let's go do that. So I've closed that ECS tab and we're back at the console homepage. Now I'll go over to server load balancer here and we'll create a SLB in the Singapore region. So here we are in Singapore. I'll click on create instance. That will take me over to the buy page for SLB. From here, I can choose my region, choose which two zones I want to support. In my case, I want zones B and C, and I need to choose a specification for this instance. Okay, so let's see, I want to have a small. Each of these specifications supports a different number of connections per second, queries per second, and max connections. So for instance, the small can handle up to 5,000 connections at a time. The high one can handle up to 200,000 connections at a time. So there is a pretty significant difference between these classes. For me, for the demo, I'll just go with small one, and I'm choosing internet, which means there will be a charge for using this instance. If I were to choose intranet, then it would be free because it would not be public facing, but I want an internet facing SLB instance so that I can show you SLB easily. I'll be using the SLB public IP address in a few minutes from within the browser to show you how the load balancing is working. So I want a public instance. I just need one. We'll create just one. And again, I want to make sure that it is using zones B and C because that's where my ECS instances are. So I'll now click on Buy Now, and that should go ahead and let me proceed to the checkout page. Once I agree to the terms of service, I can click on Activate. Once I've clicked on Activate, the process of creating my server load balancer should go ahead and start. So I can now close this tab and go back to the server load balancer homepage and refresh, and sure enough, there is my load balancer. Of course, it's not going to work yet because I haven't configured the backend servers and I haven't configured any listeners. So we need to fix that. So I'll click on the load balancer's name here, his ID, and the first thing I want to do is create a virtual server group that contains my two ECS instances. So I'll click Create vServer Group, and I'll call it Web Servers, and I'll click on Add here, and I should be able to select from the ECS instances I have running in Singapore. I just have these two, so I'll check Select All, go to Next. I'll make sure they have the same weight, so they each get the same number of requests, and they should be listening for incoming connections on port 80. And I'll click Add. And then I will click Create to create that vServer group. And now that that's ready, I can go ahead and set up a listener. So we're not quite done. We have a vServer group, but we also need to configure the listener to make sure that the load balancer is actually ready to listen for incoming requests on its public IP and distribute them to the servers in this group. So I'll click on the Listener tab, click on Add Listener, and we'll be creating an HTTP listener. We will listen externally also on port 80, and I'll call this Web Listener. The scheduling algorithm will be weighted round robin. If I want to click on that, I can click Modify and then choose a different scheduling mechanism. In my case, weighted round robin is fine. I don't need to enable any of these other things like session persistence, redirection, or access control, although I could if I wanted. I can also choose which HTTP header fields to modify or forward to my backend instances, etc. I'm going to leave all of that at the default settings. I'll click Next. Which vServer group do I want to route traffic to? It should go to my web servers group. Great. I'll click Next. And then I can set up my health check. In my case, my health check will be an HTTP health check, and the health check path will just be the root. So basically, I will just send my HTTP request to the web server root. I won't be trying to hit a particular web page. And if I get a 3xx or a 2xx response back, then we'll consider the instance healthy. I'll click Next. Okay, this summarizes all of the protocol, listener, and health check information. Also gives me a list of my backend ECS instances. Once I've confirmed that all of this is set up the way I want, then I click Submit, and that will actually put our server load balancer into a configuration where it's ready to use. So if I now copy paste this IP into a web browser, I should see that I can now see the web page that's being hosted on my backend servers. And if I refresh a few times, you should start to see that connections are in fact being distributed evenly between these two instances. So if I keep refreshing the page, sometimes I end up having my request forwarded to instance A, other times the request goes to instance B, and it looks to be about 50% of the time I go to A and 50% of the time I go to B, which is correct. If I wanted, I could change the weightings here in my listener so that the traffic wouldn't be distributed evenly between these two instances. So let's actually do that. So I'll go do that from the vServer group. So I can make, let's say that I want ECS A to get, has to be out of 100. Let's say he gets 80% of the traffic and instance B only gets 20%. And then I'll save. Now that I've made that change, let's see what happens. So now it's A most of the time, and then occasionally B. And you can see the requests are being distributed according to the ratio that I configured, so everything is working. And that's it. That's how you configure and use Server Load Balancer.